m1 into m2 g upon r square. Correct na? Simple formula what Newton gave. Now, after giving the formula was very successful. Planetary motions were well explained. And then he writes a letter to a friend, in which he says, in a letter to a friend, Newton said that gravity should be innate, inherent, and essential to matter, so that one body, without the mediation of anything else, influences another body at a distance. This very idea is so great a stupidity that nobody should, a thinking man should accept it. Sun engaged millions of miles away. Earth is here. How is the gravity affecting it? In the pole, the change, every effect of action at a distance. It is an occult phenomenon. Quantum mechanics is a different problem. Sir was talking about tunneling. The particle is here, energy barrier is here. Hundreds of particles are coming to the energy barrier, getting back, they are not able to cross it. But some of them will go the other side. How did they go? Nobody knows. There is always a probability, that's a mathematical calculus, and sometimes the probability calculus will be such, sir, more than the age of the universe. You get so frightened by the whole concept of the age of the universe that you don't question further. So that is how mathematics per se may not explain it, but it works, it gives you the answer. So this is one of the, so I come to I've got a very simple experiment, but you may enjoy it because there are a lot of undergraduate children. I thought I'll bring it there. You see, I've got a small cup. Then a cup, a small string, weight. And if I leave my hand, what will happen? The cup will fall down, gravity, correct? Huh? So I take this pencil and hang the cup. Nothing I'm doing, very simple experiment. If I leave the string, what will happen? What will happen? It is going to fall. So what I do, I leave it. Man got frightened. It didn't fall. Why? 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 or 10. It has wrapped itself. Why does it wrap itself? See, nothing. You can do it, you can take it and do it yourself. I am doing no trick. Just hold it. And by studying this simple, they came to a very strange phenomenon law called the conservation of angular momentum. And this was, conservation of momentum law was given by whom? Anybody knows who gave the law for the conservation of linear momentum? Huh? Newton. But who gave the law for conservation of angular momentum? Nobody knows. Some say Euler in some way suggested it. Some say no, Copernicus, not Copernicus. What is it? Huh? Kepler. Kepler anticipated it. Because he was measuring the area of the swept area in time per unit time, and that unit and angular momentum unit is the same. Unit is the same but arriving at a different way. So they were anticipation. And this is how, and with this last experiment I land on this line, then I go to something else. How a simple thing can explain, but not how only this happened. Because I get this question all the time from even senior students of college and all that. That if gravity is attracting, why is the planet going round and round? Somebody says, sir, it is continuously falling, but it is falling on itself. It is not able to. So these are apparently looks counterintuitive. To get over this counterintuitive, you have to do the experiment. I made a small experiment. Can you have fill this glass with water. I'll show you a very simple experiment, then I'll go to something more serious. Huh? So I created a very interesting model. I always felt proud of this invention. I wanted to create a model of the planetary motion, actually working model. So I took this James ball belonging to my granddaughter, yellow color, looks like the sun, correct? And this is a green thing, looks like an earth. Am I right or wrong? Mark, you fill some more water. I think I have to make the gravity still strong. Now see, the effect is very, very interesting. So, I am not putting on my specs. Can you remove it? Which way? I forgot to bring my specs lying in the car. So see, this is what? Earth, sun, I have to create gravity. So I thought of an idea. I put a plastic or glass tube inside, put a string, and put a weight that side. So if you don't look at the weight, you see, if I keep it here, as if broken. Can you put this back through this? From this side, can you put? No, tie it first. You have to put it. You do it. If you do it, then you can continue with it. Otherwise, you drop it because time is running out. Huh? Definitely. It's broken down. You have to. It is all homemade. So I'll come with, by the time they are doing this angular movement. You have just heard the previous lecture. Spin. Spin is there, angular momentum is there without anything spinning. Or if there is anything spinning, we do not know about it. A lot of these questions have come like this. So I created a model of spinning. Just a simple model. And it explains very well this model. The odd behavior. And sometimes you cannot see the spin and still things are spinning. Throw away this water. I am going to use the plate. This is a very simple top, Chinese top. Huh? I do not read again. It's just simple. Put it in and you keep it anywhere. It keeps rotating. It will not fall down. Like any top. You see? So, you can play with it. You can keep it in the pocket, keep it anywhere, but you will find this top is. And suppose this is put in a casing so tight, you can't see the rotating body inside. Then it will look like any mat, but behaving very oddly. Because if you take any other piece of mat and keep it like this, it doesn't fall. You can keep it over anything like because of rotation. And so I thought how to break it into parts so that each one understands. So for that I designed, again handmade, a simple base. I've got a rotator here. You see, same thing I have, but what I told them, I have added a piece of pine, extra pine, insert also for manipulation. The same top now manipulated, it becomes like a magic, behaves like a magic, and all the questions leading to angular momentum are phenomenal way to understand it. What I do, I am going to mount this. It does 1 minute. Because these are all handmade, they become also very fast. Twenty seconds. You see a very simple mounting. I mounted this. And if you leave it like it, it will fall. Huh? Nothing very simple. But when it rotates, it becomes magic. See how? To magnify the magic, I have attached it. Same top has been converted like this. Now I'm going to rotate it. If I put it down, it is rotating. If I push it in the direction of the rotation, see what happens. If I push it like this, it goes up. If I try to block it, it goes down and again moves. If I try to speed it like this, it goes up. Very strange behavior. If I try to stop it, it falls. So all again you can do. Very counter, and if you try to explain this force acting, that force acting, people tried their level best. Nothing worked. What worked? One law. Follow the principle of conservation of angular momentum. No, gyroscope you can make later. Navigational gyroscope, I'll convert it in 2 minutes into navigational gyroscope. I've got all the small pieces which you make it to navigational, because when you go into space, you do. But what is important here? The laws of physics are not to be explained in terms of why. They are just there. Why they are there, nobody knows. And there are speculations that they are going to be right all through the. No, nobody knows. We are trying to understand. Anyway, I think I had hundreds of experiments that way, but time is running out. Really racing for me. Whatever that laser was left in the car. I had a want to make the experiment. I'll explain it. Younger laser. No, that. And the laser pointer is also there. In my hurry for the class, I was so it was anyway, I'll show you how it's going to have something which is related to quantum mechanics. So simple. Listen me. No, or from okay, you can be off. So this is a thing designed by Manu, but it's really magical. You must have seen this vernier caliper. What do we nobody uses it? What we have done? Shaving blade. Shaving blade is one good quality. That is it. Technology really made it very sharp. So I got to make a slit out of it. So I started raising the blade on the caliper, and by switching it on, it shows how much? 0.01 millimeter as opening. It's not there, must be there. It's barely you can see anything. So this gives you the slit width. You can slowly, if tight, you can move it back. You can see, what is the reading now? 0.57 mm is really open. So you can control the slit width. Is how much? 0.26. So slit width, you come to know, so it's very simple device with the help of the shaving. So the shaving blade is not really fine for a different purpose. The blade manufacturer never thought using a quantum mechanics is a straight line. It's very well interesting. And mounted on a caliper. Now where is my laser? Do you have a laser pointer? I think that made a green? Huh? Red. Give it to me. No, it's not working, no battery. Can you turn it around now? Somebody has to help me. Will come? If it doesn't work, I'll take it. Just hold it. You take it. Wait a minute. I'll wait a minute. Let me see where. I got eye tracking. Battery is running out. The first thing, lesson learned, don't do the experiment in a hurry. You flip that thing and using it. Lights are there, that's why. Can you switch off the light? This also I forgot. Two bright lights. I can see the fringes, but very different from each other. Here now they are coming very well. Somebody has to. You can see the fringes. Actually, it has to be mounted on it. No, it's going out. See? I will hold it. Long press. You can see the fringes there? I now can see the fringes. I am sorry. Very good fringes. But only thing is, if you mount it properly, my hands are sick, you will see the fringes very clearly. Now you can measure on a scale the fringe. You can measure the distance. And you with the slit. So the slit shows uncertainty in position. Shows uncertainty in movement. The initial moment is always towards the screen. Going to the side. And you get the blank constant. Very cheap way. You may not be very slightly disappointed by this because this has to be held into a what you call some frame to hold it tight. This lighter has to be kept, but you can see the fringes. But you can work out the Planck's constant in this way. Very simple method. So I would have worked out the whole thing because we don't have we wanted a stand to mount it and all that. Somehow we missed it. But I think that will be sufficient. With that, I think I end it. Because something you like to ask or 5 minutes, 10 minutes, we can talk like that. Yes? So these are the very how observations and out of the box thinking, not getting carried away by dropping names. Beckino may be right, Einstein may be right, may be wrong also. So that is what is the spirit of science. And it has its limitation. For example, does science tell you anything about any physics can tell you why it look yellow or red? Can anybody tell me? The whole what you see in colors, red, blue, green, if you remove all the colors, what will the world look like? Tell me. Black is also a color actually. White is also a color. But where is the color coming from? See if you spirit tells you about wave, vibration, frequency. Physics doesn't talk about color. It is the mind which interprets impressions the mind says yellow. Right? Otherwise, from scientific point of view, all velocity is relative. Correct? So Earth moving around the Sun or Sun moving around the Earth, today scientists say both are correct. Only thing the mathematical structure will be different. But in a real life, if you put in a car and you hit a pedestrian and you say all velocity are relative, I get hit in the when I hit my car, you will not only be jailed for hitting, but also for madness, you will put it as a. So, real life is slightly different. It is not all physics or science. There's so much that doesn't take into consideration. Only in quantum mechanics we started talking about observer. Earlier, observer was something constant, nothing. Whatever I see is the truth I see. But quantum mechanics only taught one thing. The observer is as important as observed. And if the observer is different, in a different frame or different thing, observed things will be different. So the whole world is created, or the if is created, the universe is created, because of interaction between your mind, what let me say, inside you and outside. But it's a rough way of putting it. So that is how various phenomena may be explained, but don't, for the subject you will break the world into physics, chemistry, mathematics, biology. But for the general understanding, even if you are a physics student, keep your interest alive in various